Hello dear learners, you are welcome to this tutorial. In this tutorial, we are looking at the basic concept of trigonometry. So by the end of this tutorial, you will be able to represent angles based on quadrants, that is talking about unit circle, and you will also be able to solve problems involving trigonometric ratio of acute angles. My name is Ademola Folarin. This tutorial is powered by Yota Virtual Learning. So let's start learning. If we have a circle of radius 1 unit in this manner, it tells us that if we read the angle from this place, if this is 0 degrees, and this place is taken as 90 degrees, this place can then be taken as 180 degrees, this place taken as 270 degrees, and if it flip back here, we can as well have our 360 degrees here. So in this unit circle, it basically represents angles in quadrants. So this is how, when a circle rotates in this from 0, it rotates 90 degree, 180, 270 and back to 360 in degrees. But if we are representing this in radian, this part will be seen as 0 radian. If it moves to this place, this becomes pi over 2. That's another way we can represent 90 degrees. So in degrees, it is 90 degrees. In radian, it is pi over 2. And when it is 180 degrees, the radian form is pi. So that means from 0 to 180 is pi in radian, while it is 0 to 180 in degrees. So in 270 now, the radian form of 270 will be 3 pi divided by 2. And when it goes back to 360, the radian form of 360 will be 2 pi. So in radian form, what you call 180 degrees will have its radian form to be pi. This is in degree form, this is in pi form. So that is application of unit circle in trigonometry. And let us not forget what we've learned in the basic trigonometry is that at this angle, which is between 0 and 90, here 0 degree, theta is between 0 and 90 degrees. At this point, all of the trigonometric ratio, that is the sine theta is positive, the cos theta is positive, and as well as the tan theta, it is positive. So any angle from 0 degrees to 90 degrees, when you check their sine, cos, and tan, they are always positive. But once it moves to the second quadrant where theta is between 180 degrees and 0 degrees, and 90 degrees, where theta is between 180 degrees and 90 degrees. That is at the second quadrant. Here at the second quadrant, only the sine is positive. Only the sine is positive. All others are negative. That is, cos is negative and tan is as well negative. So if we are given an angle, let's say we are given angle if our theta is 140 degrees. So if we are looking for tan 140 degrees, the tan 140 degrees can then be expressed as negative tan 180 degrees minus 140 degrees. Because 140 is on the second quadrant, so it's negative. And when we take this, it can then be expressed as tan 40 degrees. You will observe that if you check through your calculator or your four-figure table, or let's say your calculator, when you press tan 140, is equivalent to saying you press negative tan 40 degrees. When it is at the second quadrant. At the third quadrant, only the tan is positive. All others are negative at the third quadrant. Only the tan is positive. All others are negative at the third quadrant. So we represent that the third quadrant is between 180 degrees and 270 degrees. 270 degrees. Third quadrant. So the third quadrant, the sine takes negative, the cosine takes negative, but the tan takes positive. Using the generic formula of theta minus 180 degrees. Take for example, you are interested in finding tan, what falls into that, tan 210. Tan 210 degree is equivalent to saying plus tan 210 degrees minus 180 degrees, which is equivalent to saying plus tan 30 degrees. So you get to realize that the tan of 210 degrees is the same thing as the tan of 30 degrees. But if it is sine 210, sine 210 is the same thing as negative of sine 30 degrees. And at the fourth quadrant, that's the quadrant where only cos is positive. Cos is positive, sine is negative, and the tan is also negative. So it is only cos that is positive here. This one takes value from 271, that is, the theta is between 270 and 360 degrees. 270 and 360 degrees. So any value from 271 to 360 degrees falls on the fourth quadrant. And it always follows that plus cos theta in this point is always plus cos 360 degrees minus whatever value of theta that we are using. For the sine is going to be minus sine 360 degrees minus the value of theta. Here the value of theta ranges between 271 and 360. And it's the same thing for the tan theta at this point. So this is basic representation of angles between 0 and 360 degrees. Very interesting. So if we have a situation where we are asked to find the value of, let's say for example, we have here tan 255 degrees. Remember, you do not have calculator, but you have your 4-figure table, and 4-figure table can only help you within angle of 0 to 90 degrees. So if we are to express tan 255 degrees, so what we do is that 255 degrees falls into what quadrant? Is more than 180 and it's less than 270. So automatically it falls at the third quadrant. And when it falls at the third quadrant, it becomes plus, because tan is positive at the third quadrant. That will be tan 255 degrees minus, we have it as tan 255 degree minus 180 degrees. So that will give us positive tan. Take 180 degrees from 255, that's 75 degrees. Yes, tan 75 degrees. So that's the equivalent of it. That is interesting. Now we understand that we can then look into trigonometric function of acute angle. When we say trigonometric function of acute angle, this is basically a situation where angles are represented, angles that are below 90 degrees. Take for example, we have something of this nature. If this is a right angle, remember we've learned before, this is hypotenuse. So if we are considering, let's say, this angle, which is less than 90 degrees, the side facing it will be opposite and the third side will be the adjacent. So the basic of this tells us that the sine of angle theta will be equals to the ratio of opposite side to the adjacent side. That is, opposite side to the hypotenuse side, opposite side to the hypotenuse side. The ratio of opposite side to the hypotenuse side, if it is cos theta, is going to be the ratio of adjacent side to the hypotenuse side. The ratio of adjacent side to the hypotenuse side. And if it is the tan of theta, the tangent of theta, is going to be the ratio of opposite sides to the adjacent side. So to remember this, we have an acronym for it. If you remember in your grade 7 or grade 8, you've learned something of SOHCAHTOA. That is, sine theta is equals to opposite over hypotenuse, while cos theta is equals to adjacent over hypotenuse, and tan theta is equals to opposite over adjacent. So it makes it easier for us. There are situations where we are given sine theta. Let's say sine theta is given for a particular value, and they may ask us to find cos theta. So using the knowledge of sine theta to find cos theta, and that is problem involving trigonometric function of acute angles. So let's take some WAEC examples. Looking at this problem, we have it as, if sine theta is ratio of 3 to 5, find tan theta, given that theta is less than 90 degrees. So how do we go about this? Since theta is less than 90 degrees, so automatically the theta here is an acute angle. So the simple approach of it, let's sketch a triangle to illustrate that. Remember, it has to be a right angle triangle, so we can bring out the acute angle there. So in this situation, This is angle 90. If this is our theta, that means the sine of theta, remember sine theta is opposite to hypotenuse. So invariably, this is the opposite, which is 3. Hypotenuse is 5. And remember, for us to have tan theta is the ratio of opposite to adjacent side. So we need to find the adjacent side, which is not known. To do this, we use the knowledge of our Pythagorean theorem. The knowledge of Pythagorean theorem says the square of hypotenuse side is equals to the sum of the square of adjacent side and opposite side. So in this situation, we have the hypotenuse to be 5. So that will be 5 squared is equals to the adjacent is not known, adjacent square, plus the opposite square, which is 3 squared. So here that will be 25, bringing this to this place, minus the square of 3 as 9 equals adjacent square. And at the end, this will be 16. So square root of 16 will give us the value of the adjacent side. And then the adjacent side will be equals to 4. Now that we know the value of adjacent side to be 4, we can then come to see the tan theta here will be equals to the opposite, which is 3, to the ratio of 4. Isn't that interesting? So using the knowledge of acute angle. Better still, if this doesn't come to your mind, you may as well use another method. Now let's look at it. We are already given this. We are interested in finding tan theta. Recall that tan theta equals the ratio of sine theta to cos of theta, cos theta. So to make it interesting, we already know sine theta to be the ratio of 3 to 5. And if we remember in our basic trig, one of the trig identities that we must recall is that cos square theta plus sine square theta is equals to 1. So we can then say cos square theta will be equals to 1 minus sine square theta, which you can say 1 minus, our sine theta here is 3 over 5. Then let's square it. It means 1 minus 9 over 25. So if we simplify this, that will give us LCM 25. 1 in 25, that's 25, minus 9, that is 16. So cos square theta is equals to 16. That means cos theta in this situation will be square root of 16 over 25, which will give us 4 over 5. Now that we know the value of cos theta to be 4 over 5, we can then say, therefore, tan theta is equals to the ratio of sine theta, which is 3 over 5, divided by cos theta, which is 4 over 5. And we can say 3 over 5 multiplied by 5 over 4. Remember, in our basic way, the 5 can cancel out 5. Then the tan theta in this situation will be 3 over 4, which is the same thing as what we've gotten here using this method. Oh, you find that interesting? That's great. Let's look at another problem. This problem says, given that tan x is equals to 5/12, we should find the value of sine x plus cos x. We are interested in finding the value of sine x plus cos x. So to approach this, just as what we did in the last question, we sketch a right angle triangle. Sketching a right angle triangle. Recall that if this part is our angle theta, then the opposite is this angle, the adjacent is this, and the hypotenuse is this. Since our tan of any theta, let's say tan x, is equals to opposite over adjacent, that means the opposite here is 5 and the adjacent is 12. We are interested in hypotenuse because we are going to need the hypotenuse for the sine x and cos x. So to do that, we quickly say the hypotenuse square using Pythagoras theorem equals the square of the opposite side, that's 5 squared, plus the square of the adjacent side, 12 squared. This gives us 25 plus 144, and this gives us 169. That's the hypotenuse square. So hypotenuse itself will be square root of 169, which is 13. Now that we know that to be 13, it's now easy for us to say sine x. Remember, sine theta is always opposite over hypotenuse. So since the hypotenuse is 13, the opposite is 5. That will be 5 over 13. And cos theta, that's cos x, is equals to k, adjacent over hypotenuse. And that will give us 12 over 13. Now that we've been able to spell those things out, we can now see sine x plus cos x will be equal to the value of our sine x now, which is 5 divided by 13 plus 12 divided by 13, which is the value for cos x, will be equal to 13, 5 plus 12, and hence this gives us 17 over 13. So we can conclude that this sine x plus cos x equals 17 over 13. We may as well express it as one whole number, 4 over 13, in an acute form. It's interesting. Good. So let's take one more example. This one says, given that sine x is 5 over 13, for x between angle 0 and 90 degrees. So how do we approach this? We are to find this value. So to do this, we just simply draw the right angle triangle. Since it's an acute angle, we draw the right angle triangle. That gives us something of this nature. So drawing the arc, we can spell out the opposite. Since sine is opposite over hypotenuse, if this is our theta, the opposite is 5, hypotenuse is 13. So our interest is to find the adjacent. Here we can then say adjacent square is equals to the square of hypotenuse minus the square of opposite, which is 169 minus 25. That gives us 144. Remember, this is adjacent squared. Therefore, adjacent will be equals to the square root of 144, which is equals to 12. Now that we know the adjacent sides to be equals to 12, we can then express the value of each of them. Now we can express the value of what we are given here that we are interested in, cos theta, that is cos x, and as well as the value of sine x. So, okay, sine x is given. We express the value of cos x and tan x. Remember, the cos x in this form, let's cover this. Cos x will be equals to adjacent over hypotenuse. The adjacent here is 12. That's what we just got over hypotenuse. So that will be 12 over 13. And the tan x will be equals to opposite over hypotenuse. Opposite over adjacent. Opposite over adjacent. That is 5 to 12. Now that we know this, the problem at hand, which is cos x minus 2 sine x divided by 2 tan x, will then be equals to the cos x given to us is ratio of 12 to 13 minus 2 the sine x, which is 5 over 13, all divided by 2 into bracket of 5 over 12, which is tan x. So reducing this, we'll have 12 over 13 minus 10 over 13, all divided by 10 over 12. So this goes ahead to say the whole of the numerator here will be 13, 12 minus 10, that is 2, all divided by 10 over 12. And that can be said as 2 divided by 13 multiplied by 12 divided by 10. So we can reduce this to say 2 goes here, 1, 2 goes here, 5. So that will give us 12 divided by 5 times 13. So 5 times 3, 15, 5. That's 65. Hence, we can say the answer to this problem here is equals to 12 divided by 65. So if you enjoyed this, you can as well leave your comments, questions, or suggestions in the comment section below. And as well, subscribe to this channel, click on the like button for more interesting tutorials like this. Till I come your way next time, continue learning mathematics.